Hello guys, welcome back to my YouTube channel. I'm Scholastic Sam, and today, in the next lesson of our chemistry unit, we are going to be going over lesson 1.4, Radioactive Decay. Now, before we start with radioactive decay, it's important to know the difference between a nuclear and a chemical reaction. Now, chemical reactions change the electron cloud, while nuclear reactions change the nucleus. And chemical reactions don't change the identity of the atom, meaning they don't change the element, but nuclear reactions do. And chemical reactions only release a small amount of energy, while nuclear reactions release a lot of energy. Now, you go into radioactive decay is a nuclear reaction. It's when in a stable nucleus, usually the strong nuclear force will outweigh the repulsions of the positive protons, and it won't decay quickly. But unstable nuclei undergo radioactive decay spontaneously. Now, there are three types of radioactive decay, and the main ones are alpha decay, beta decay, and gamma decay. Now, when we're doing the reactions, it's important to understand the law of conservation of mass, which states that matter cannot be created or destroyed. When applied in chemistry, it means that the amount of mass on one side of the equation must be equivalent to the mass on the other side. So when we're showing this radioactive decay, the element we start with has to have the same mass as the element and whatever is released that we end up with. Now, the first type is alpha decay. Alpha decay releases a helium nucleus. This means that we take an element and its mass, if we'll have carbon-14, something like that, and then we take away helium-4, meaning we take 4 away from the mass and 2 away from the protons. Then we write carbon-14 to helium with 4 mass and 2 neutrons plus whatever our new element would be with its mass and its protons. This will make more sense after we do our practice problem. The next one is beta decay, which releases a high energy electron, and a neutron is converted into a proton and an electron. So what you do is you take an element and then you draw your arrow to indicate the products, and then you do beta, or some people will do the E sign for an electron, but we're going to do beta with no mass but 1 proton plus whatever we started with, but instead it has 1 more proton. That says P equals P minus 1, because it gets confusing because it's releasing a proton, or it's releasing a proton, but then the new one has to have 1 more. So it'll make sense. It'll all balance out when I show the practice problem. So then we write a new element in its mass. For example, if you have something with 10 protons and a mass of 19, it would just be something else. It would be the new element with 11 protons and a mass of 19. Our final one, the easiest to understand, is gamma decay. It releases high energy gamma rays, but no particles are released. So the mass and the identity stay the same. You'll have an element and its mass, and you star it. And then you draw your arrow, and then you draw a gamma symbol, which looks like this. You probably couldn't see that well, but I'll show it to you guys. And then you write it without a star, and then you write plus an element, but it's just the same element. So if you have hydrogen 1, you put a star next to hydrogen 1, plus gamma with no mass and no protons, plus just hydrogen 1, but it wouldn't have a star. Now, let's go on to our practice problems. First one is going to be the alpha decay of francium-211. Now, let's put this back a little bit so I can draw better. Yes, yeah, you guys can still see that. So francium-211 is FR, I think it's francium is 87 protons. 87, and it says 211 up there. Then it decays, so we draw our arrow, decay, and then we know we take away helium-4. 4 with 2 protons. Plus, and we're trying to figure that out. So now, we need to find out what's there. And you can do this inversely by taking whatever's here and using some simple algebra to find out what's there. So we just do, to find out what we're adding to helium, we just do 211 plus blank, or plus, sorry, wait, dang it. It's 211 minus 4 equals what? Well, it's going to equal 207. So we know our mass is going to be 207. So remember, law of conservation of mass, it has to be the same as that. Then we have 87 minus 2 equals 85. So we know the amount of protons is 85, meaning that's going to be the 85th element. Now, what's the 85th element? It is AT, or astatine, as you guys can see right there. So we draw AT, and boom. That right there is alpha decay. Now let's move on to beta decay. So if we have carbon-14, we know that that's just going to be C with a mass of 14, and we know that carbon has 6 protons. Then you're going to draw the beta sign, which just looks like a B with a really long end. Beta. And we know there's no mass somehow, but it has 1 proton. So plus what? Wait. Let's see if we go down. Here, I copied them there. We see that, it's -1. So I kind of long to, I wanted to make sure I got it for you guys. You have -1. So then we have 6 equals -1 plus what? Well, equals -1. 6 minus -1, the same as 6 plus 1 is 7. So we know we're going to have 7 protons, and then 14 equals 0 plus, well, what is it? 14. So we're going to have 14 neutrons. Or it's a mass of 14. And then we do 6 plus 7. Our 7th element is nitrogen. So N. And then that's right there is our beta decay equation. It looks kind of like a greater than. Let me fix that. 7. Now let's go into our final one, which is gamma decay of barium-137. So we have B. What's the time here? 8 minutes. BA. Then we have 137. Then how many protons here? Barium, 56. 56. But we put a star here. The star is important. That's what lets us know that gamma decay is going to happen. And we go, boom. And we just have a gamma with no mass and no proton. And we know 137 plus 0 equals, I'm just showing this for you guys, but you should be able to do it in your head. Or a test or something, I recommend showing your work for the other two. But this one, it's not necessary. The star is the only part people forget sometimes. 56. Oh, it should be 56. Hold on. 56. 137 equals 0 plus 137, and 56 equals 0 plus 56. So again, we know it's going to have 56 protons, 137 mass, and then we just know, and we put BA because we know it's going to be the same element, but this one, just only difference, no star. So boom, there we go, guys. Those are the 3 types of decay. Now, if you want a quick recap, you can look at these ones. That's the alpha decay. That's what I did. But it's a little neater there. That's the beta decay, but it's, again, they wrote I wrote E. You can do either one, depending on what it asks for. And then there's gamma decay. So yeah. Thank you guys so much for watching this video. Shout out to my chemistry teacher, Dr. B, for teaching me all this information. You guys could hit that like button and subscribe. It helps grow the channel and helps this knowledge reach more people. If you guys could please turn on post notifications so you can get updated whenever I post a new video. That way you guys can keep learning this stuff throughout high school, because you're going to need it so you can ace high school with ease. Because these videos make high school easier, and they help you do well, which you're going to need. So, yeah, and if you have any questions, comments, or concerns, please put that in the comment section, because I do respond to all comments. Yeah, thank you guys. Bye. Join me for my next video. I think we'll be learning about nuclear fission and fusion. And always remember, knowledge is power.